Alright, let's go ahead and get the Springs TEKS unit test review done. So, let's go ahead and take a look. 25. Given the function f of x equals 3x minus 5, find the value of x when f of x equals 7. Now, whenever it's outside the parentheses, what you're going to be looking for is going to be your y value. So, what we got to do is, we got to set this equal to 7 is equal 3x minus 5. So since this is a pretty calculator intensive class, let's go ahead and just go ahead and use our calculator. And so on the left side, we go ahead and adjust this. There you go. We put 7, and on the y2, we're going to put the right side, which is 3x minus 5. We look at the table, we see where they match. Boom. X is 4 when y1 and y2 are 7. So the solution is going to be x equals 4. Now likewise, number 26, given the function g of x squared, g of x equals x squared minus 4x minus 10, find the value of g of x equals 2. Again, this is going to be outside the parentheses, so it's your y value. So let's go ahead and skip to the chase. We'll put the first equation into y1, x squared minus 4x minus 10, and the next equation into y2, which is 2. Look at the table. It matches at 6, and it matches at 6. See how it's got 2 and 2. And let's see where else it matches. And at negative 2. So we got negative 2, 6, where y1 and y2 are the same. So we have x equals negative 2 and 6. 27. The graph of h of x equals negative 3 over x plus 2 is shown on the right. What is the value for which h of x equals negative 3? Again, it's outside the parentheses, so they're talking about the y value. So we go look. The y value at negative 3 is right here. So when the y value is negative 3, the x value is going to be negative 1. X equals negative 1. 28. Some values of the function f of x equals 3 raised to the x minus 1 are shown on the table below. Which of the following is true about the solution to the equation f of x equals 10? So again, f of x is outside the parentheses, so this is your y. Here's also your f of x, so you got 0, 2, 8, 26. So 10 should be found somewhere in between when x is 2 and when x is 3. So this will be D. 29, given the function h of x equals 2 square root x minus 3, find the values of x when h of x equals 4. Let's go ahead and just use our handy dandy calculator. 2 square root x minus 3, and again h of x is outside the parentheses, so that's going to be a y. So we're going to put a 4 right there. So we're going to look at where y1 and y2 are the same. 7. So let's take a look at the graph just to make sure there's only one solution. And sure enough, if you look, it's only going to touch once. So it's going to be x equals 7. 30. Given the graph of f of x equals 5 log x plus 3, what is the value of f of 1? So this one is inside the parentheses, so your x value is 1. So here we look at the graph. Oh, wrong way. Oh, wrong button again. There you go. So we look for where the x value is 1. We go up, and here. When the x value is 1, the y value is going to be 3. Alright, next side, 31. Sum of the values of g of x equals negative 1/2 x plus 4 raised to the third power plus 3 are shown below. What is the approximate solution of 5? And then that equation that I just said. So the one that is instead of y is 5. So we're going to go here and look at 5. So, not here, not here, not here. Well, I don't see 5. However, I look at the x, and it's going down by 2's. And here is about where 5 should be. Somewhere in here. So it says it's an approximate solution. So I'm going to approximate that my solution is between, now it really has to be between, negative 6 and negative 4. Alright, that's a good approximation, or good enough. Alright, 32. And the height of the ball 2 seconds after it has been thrown into the air from the top of a building can be modeled by h of t equals negative 816 t squared plus 48t plus 64, where h of t is the height in feet. How many seconds does it take for the ball to hit the ground? Let's use our calculator. So we go to y equals negative 16x squared. Oh, let's put it here. Negative 16x squared plus 48x plus 64. And in y2, for it to hit the ground, the height has to be 0. So I'm just going to put 0. We look at the table. It will be at 4. So because the t is the seconds in time, it's going to take 4 seconds. Alright, 33. The radius of the circle, RA, can be represented by that formula with A representing the area of the circle. The graph of this function is shown below. If the points 28, 3 is on the graph of R of A, what is the meaning of this situation? This is point for the situation. So here we go. The x value is 28. The y value is 3. So when we look at 28, it means that the area of the circle is 28. So when the area of the circle is 28, then here's a 3. Then the radius of the circle is going to be 3. So let's read. When the area of the circle is 28, the radius is approximately 3. That's exactly what I just said. So that is correct. 24. The table of values for the exponential function f is shown at the right. The values represent the value of a car over a period of 5 years since it was purchased. Use an exponential regression to determine a function for this data. So whenever you are doing exponential regressions, it's your initial times your rate raised to the x. Your initial is 25,500. So I can eliminate D and A. And your rate is 0.485 in both. It's not x minus 1. It's just x. So it's going to be C. You can also put this in your calculator, and you'll see that the tables will match. All right. Which set of data will best model an exponential function? Now, remember, exponential functions look like hockey sticks. The only one that kind of looks like a hockey stick is D. All right. All right. Let you guys read that. What type of function would best model this situation? So, this situation is AU. AU is a parabola, and a parabola is quadratic. So it's going to go ahead and go with quadratic. So you get the calculator. Do second plus 7, 1, 2. And this is how you go. You go second, 0 to get to the catalog. Then you scroll down until you find diagnostics and turn them on. Then go to stat and enter your data given to you. So 2, 6, 8, 10, 12, 14, 16, 18, and 22. And the area will be 44, 108, 128, 140, 144, 140, 128, 108, and 44. Now, it's quadratic, so now we press the stat button and we calculate a quadratic regression, which is the 5th option. We see it has an R value of 1, so it's a perfect match. The A is -1, so this is going to be, put myself in here, negative 1x squared, or just x squared, plus 24x. Now it's 0, so I don't need to write anything afterwards. So we're going to start, put a y equals in the front, and we're good. Alright, determine the function model. Oh, this goes right here. Alright, it's y equals negative x squared plus 24x. Alright, determine an equation that can be used to model the data below. Alright, so let's go ahead and see if linear is a good fit for this. So I'm going to go to stat, edit. Now we have the previous data in there. I'm just going to clear it, pressing the clear button. Press enter. All that data goes away. Clear enter. All that data goes away. So let's go ahead and put the data in there, which will be 0, 1, 2, 3, 4, 5, 6, and 28.2, 28.5, 28.9, 29.1, 29.4, 29.8, and 30.1. Put that in there. Stat, calc, linear regression. And I see the R value is 0.9979. So it's pretty good. So we're going to go ahead and go with this. And we're going to have y equals 0.314x plus 28.2. Now 39 tells us what to use. Exponential regression. Find the exponential regression of the regression equation to represent the data. So you go in here, stat, enter, clear your data from before, and let's go ahead and put it in. That's going to be 0, 20, 40, 80, 120, 180, 220, and 300. And on the right, it'll be 200, 179, 160, 128. Let's a little bit higher. 102, 73, 58, and 37. Alright, now that my data is in there, I go stat, calc, and exponential regression is going to be the 0th option, or 10th option. And we find that it's going to be 200.39, let's do 200.39. Y equals 200.39 times my B, which is 0.994. So I'm going to put that in parentheses. 0.994 raised to the x. All right, ladies and gentlemen, that's the end.